To start the experiment, choose the metal measure of desired capacity depending upon the size of the aggregate. In this case, since the size of the aggregate is 20 mm, the metal measure of 15 liters capacity is used for the test. Take the empty weight of the metal measure.
So we took the empty weight of the container's weight. Okay, so weight of the measure is, we noted it down. And
now fill the measure loosely with the aggregate to overflowing by means of a scoop.
Now we will fill the aggregates in 3 layers. Okay, so first layer, this is the first layer.
The height of fall of aggregate should not exceed 5 cm from the top of the measure.
So when you drop the aggregates from the
care
scoop,
should be taken to prevent the segregation of the particle sizes of the sample. The surface of the aggregate shall then be leveled with a straight edge. Now take the weight of the metal measure and loosely filled aggregates. This weight is 32.4 kilograms. Record this weight in the observation sheet.
This is weight of the measure plus loose aggregate. Means like we did not compact these aggregates, we just fill the aggregates as it is. So that's why it's called loose.
The net loose weight of the aggregates can be determined by subtracting the empty weight of metal measure from the combined weight of metal measure and aggregates. This comes out to be 32.4 minus 12.6, which is equal to 19.
So here you can see that 32.4 is the net weight of the loose weight of aggregate, plus we had container also, minus we are going to subtract the weight of the container because we only want the weight of the loose aggregate. That's why we are going to subtract the weight of container from both of them.
0.8 kilogram. The loose bulk density of coarse aggregate can be calculated as 19.8 kilograms divided by 15 liters, which is equal to 1.32 kilogram per liter. Take another set of readings and record it in the observation sheet. Average of 2 readings is taken as the final value. In this case, the average value of loose bulk density is 1.325 kilogram per liter.
So guys, here we are taking two types of bulk density. Okay, number one was the loose bulk density. That is the density of aggregates when the aggregates are loose, matlab without compaction. We are going to we calculated the bulk density. Now we are going to calculate the bulk density when the aggregates are compacted. That's why it's called rodded bulk density also, because we are going to compact the aggregates with the rod. So now in this one we are going to put the aggregates in 3 layers, and after each layer we are going to compact it 25 times. We will see it here now.
Now we shall determine the rodded bulk density of the coarse aggregates. To determine the rodded bulk density of this aggregate sample, the same metal measure of 15 liters capacity is used. For this, fill the metal measure about 1/3 full with thoroughly mixed coarse aggregate. Tamp the aggregates giving 25 strokes using the rounded end of the tamping rod.
So we are going to tamp it 25 times with the tamping rod.
Now add the second layer of aggregate using similar quantity of aggregate and again tamp it giving 25 strokes. The aggregate shall finally be filled to overflowing and tamped 25 times. The surplus aggregate is struck off using the straight edge. Now weigh the metal measure filled with compacted aggregate. This weight is 34.4 kilograms. record this weight in the observation sheet. The net weight of the aggregate in the measure is determined by subtracting the weight of the empty metal measure from the combined weight of the metal measure and rodded aggregate. Net weight of the aggregate shall be equal to 34.4 minus 12.6, which is equal to 21.8 kilograms.
So guys, see, if you see it here, you can see the difference. When we did not compact the aggregate, that time the total, when we did not compact the aggregate, then let us see, when we did the same test with loose aggregate, then the weight of the loose aggregate was how much? 19.8 kg. Can you see the difference? With the weight of the loose aggregate was 19.8 kg. But now when we compacted the aggregate, which means now the weight of the aggregate increased. It's now 21.8. Before it was 19. So almost 2 kg of aggregate has increased. Why did this happen? Why we used the same container, right? But why did this happen? Why there is an increase in the weight of aggregate? Because in the loose aggregate there were more voids present, there were more gaps present, whereas now when we compacted, what did we do? We removed the air voids and more aggregates were occupied, like the gaps where the air voids were occupied by more aggregates, due to which now the weight of aggregate has increased, because the voids have decreased after compaction. That's why there is an increase. Okay, so obviously if there is an increase in the weight of aggregate, then even there will be increase in the bulk density. So if you compare the bulk density between loose and the compacted, then obviously the bulk density of compacted aggregates will come more.
34.4 minus 12.6, which is equal to 21.8 kilograms. Rodded bulk density is calculated by dividing the weight of compacted aggregates, which is 21.8 kilograms, by the capacity of the metal measure, which is 15 liters. The rodded bulk density comes out to be 21.8 kilograms divided by 15 liters, which is equal to 1.45 kilogram per liter. Take another set of readings and record it in the observation sheet. Average of two readings is taken as the final value. The average value of the rodded bulk density in the present case is 1.455 kilogram per liter. The percentage voids in the aggregates can be calculated using the relation.
So here, see guys, now we know how to determine the bulk density of aggregate. Okay, and here in this video they have shown a very good comparison between bulk density of loose aggregate and the bulk density of compacted aggregate, or the bulk density of rodded aggregate. And your observation was the weight of the aggregates in the compacted after compaction was more, because of which bulk density is also more. So this is it for our lecture 10. In next class we will continue with the remaining properties of aggregates. Thank you.